Good morning, everyone. Great to see all these familiar faces and new faces. I'm Dr. Aaron Hall, the Beaver Corps Program Director at Beaver Institute. I'm excited and super pumped to introduce Dr. Ellen Wohl today. She's our Professor of Geology right here at Colorado State University. She's going to be talking to us today about beavers in Colorado, the once and future ecosystem engineers.
Yeah, thanks very much. It's a pleasure to be here. I do feel like I'm preaching to the choir, but that's okay. So I want to step back. Emily gave us a really nice overview of beaver and their effects on the landscape in the context of fire and drought. But I want to step back a little bit in time and space and just acknowledge that I say the northern hemisphere here. It's the whole world, particularly the temperate latitudes. But in the context of beaver, it's the northern hemisphere. River corridors, riverscapes, river ecosystems, whatever you want to call them, have been very substantially and extensively altered since basically industrialization or even since the start of agriculture. So most of what we've done is to simplify river corridors. And I use that term to refer to the active channel, the floodplain, and the water underneath the surface, underneath those two features. We've simplified and homogenized them by doing things like straightening channels, stabilizing the banks, blocking off overbank areas, blocking off secondary channels, removing beaver dams, removing log jams. It can be a very long list. Of course, we've regulated flow with dams and diversions. And again, we've removed those instream obstacles. So the two photos here, the one on the left, fortunately doesn't look like this anymore. There's been river restoration there, but it's a good example of a lot of our history of modifying rivers just to make them more efficient conveyance, get the water downstream fast, and end of story. The photo on the right is a very natural river in the interior of Alaska, the main stem Yukon. So I'm going to use the phrase spatial heterogeneity. It's a mouthful. I sometimes just call it messiness. It's anything that makes a channel and floodplain differ from an irrigation canal. And I use an irrigation canal because it's the simplest way you can get water efficiently downstream. It's straight, it's uniform, it's designed to be very stable. Spatial heterogeneity would be secondary channels, meander bends, off-channel floodplains, floodplain wetlands and lakes, log jams, beaver dams. Basically, we've lost a lot of that spatial heterogeneity, and because of that, in a sense, our rivers are more leaky. We engineered rivers to get the water downstream fast for flood control or to get boats downstream without hitting things, initially for steamboats and subsequently for barges. But we get everything else downstream fast, too. So water, whatever is dissolved in it in the form of solutes, sediment, particulate organic matter, things that we don't necessarily want to have move downstream very fast, as reflected in the dead zone, for example, that is present in the Gulf of Mexico, where everything goes downstream really fast in the Mississippi. So we've had a lot of unintended secondary effects on water quality, on the amount of plant and animal and microbial bodies, so biomass, and the diversity of species in river corridors. And I tend to think of river networks as beads and strings, and those phrases are not mine. They come from work by Jack Stanford and James Ward back in the 1990s, but they were saying, well, when you look at a lot of rivers, particularly in high relief environments like the ones to our west, what you see is, if you're looking at Google Earth, for example, or other satellite imagery, you see something that's very narrow, that's confined by valley walls, it looks like a string, and then you see these wide, flatter areas that they referred to as beads. So some examples, North St. Vrain Creek is just to the west of us in Rocky Mountain National Park. This is a Google Earth view. The string on the upstream end, the flow is going towards the bottom of the photo, is naturally confined. It doesn't have a lot of spatial heterogeneity. It's kind of what most of us would think of as a mountain stream. But then it goes into a beaver-meadow complex that's just upstream of Route 7, if you're familiar with the area, and that's a really nice bead. So the beads are not just wider, they're far more retentive because there are all these places that water and sediment and solutes can go. The bead that I'm showing here breaks up into a whole series of channels because of beaver modifications. Some of the water sits at the surface for a while in ponds. Some of it goes into plant tissues. Some goes into the subsurface to recharge the aquifer. And anything going with the water, like solutes, moves more slowly. So beads are more retentive. And they have a lot of habitat diversity. There's a lot of that spatial heterogeneity, individual patches of water, ponds of different ages, vegetation types of different communities, different age structures. So they're very biologically productive. And that retention, again, is reflecting the spatial heterogeneity, the fact that everything isn't being shunted downstream in one single, simple channel. It's also reflecting what river scientists refer to as lateral and vertical connectivity. So if I am a river flowing towards you, this is longitudinal connectivity, just moving downstream. Lateral connectivity is water going from the channel to the floodplain and back in the surface and the subsurface. Vertical connectivity is water going into the sediment below the channel. It often will flow for some distance and then return to the surface, and that's very important for river ecosystems. And as Emily really outlined or summarized very, very nicely in her talk, beads are also more resilient to a variety of disturbances. Fires and droughts are examples of those, but they're also more resilient to a lot of things that we do, human-induced disturbances. And I think an important point is the beavers don't create these wide valley bottoms, but they do make them more functional. The wide valley bottoms are reflecting things like geologic structure, glacial history, but if you just have a wide valley bottom, okay, you get some attenuation of materials moving downstream. There's more area for the material to move into. But if you have all these obstacles in there, and the obstacles would be beaver dams, beaver canals, dense vegetation, things facilitated by the beaver's presence, then you're really modifying the bead, making it more spatially heterogeneous or more messy, and really slowing down that longitudinal connectivity. So just to illustrate this, these are both photos from the west side of Rocky Mountain National Park. That's a classic string. There's really no floodplain. It's a bouldery channel that's very steep and confined on the sides. Moving downstream in the same creek, this is what a bead looks like. This is all beaver modification. There are no beaver there now, but the effects persist, at least for a number of decades. It's not clear how long they may persist. So I've used this phrase river corridor, and I use that because if I say river, almost everybody just thinks of the channel. And that's really ingrained in how we think about rivers. You know, if you think about the United States, we have the Clean Water Act, we have federal jurisdiction for navigable waters. We have nothing analogous for the floodplain or the underlying water, but they're intimately connected to the channel. So I like to think of it as a river corridor, and most people would think of these parts. There's water and whatever is dissolved in it moving downstream. There's some things coming in from the sides. But in reality, there's all these exchanges. It's a strongly three-dimensional system. And again, the net effect of our modifications and engineering over the last 2 centuries in this part of the world has been to emphasize that longitudinal connectivity and reduce the vertical and lateral. And the bead portions, they're wider, so they will always have a little more lateral and vertical connectivity unless there's artificial levees. But they can have much more spatial heterogeneity and connectivity if you have things that are creating obstructions, such as beaver dams or secondary channels. Okay, so coming back to spatial heterogeneity, this is North Inlet Creek on Rocky Mountain National Park. Again, a Google Earth view. You can see the shadows of abandoned channels there. You can see the contemporary channel. This was an area that once had a lot of beaver activity. The beavers are no longer present. And you can compare this to someplace like the North Fork of Lake Creek, which is near Independence Pass in Colorado, and you can see the difference. The beavers, where they're active, are of course creating dams, ponds of different ages, so much greater surface water, and again, the potential for greater attenuation or slowing down those fluxes moving downstream. So as a river scientist, when I look at something like this, it's a river corridor on the western side of Rocky Mountain National Park, I think of it like that. There's a lot of different forms of connectivity. They're present to a greater or lesser extent. Not all rivers have huge amounts of lateral or vertical connectivity, for example. It varies with the context. But there are these multiple dimensions to how materials, but also organisms are moving. And if you look at the upstream, downstream, you may be thinking, well, water only goes downstream. But of course, organisms go upstream, a variety of organisms, most famously fish that migrate. So Emily talked about resilience in the context of drought and fire. Beaver meadows are also very resilient to floods. For those of you who are from Colorado, if you were here in 2013, I had been working on this beaver meadow in Rocky Mountain National Park, and we had the big flood, and I was desperate to get up there. And first, all the roads were out. There was no way to get from Fort Collins up to the park. And they got some of the roads open remarkably fast, and then our government shut down, so the park was closed. But when I did finally get up there, I went to the head of this beaver meadow, and I couldn't tell there had been a flood until I really started to poke around and find sediment and large wood deposited at the upstream end. And if you look at that lower photo, that was taken when the willows were just leafing out. If you've ever been to the Wild Basin area of the park, it's, I don't know, some kind of a interesting challenge to try and force your way through that beaver meadow. It's very, very dense. And river scientists call that hydraulic roughness. It's as though I was to suddenly run as fast as I could right through the middle of this audience, and I'd encounter a lot of obstacles. So water does the same thing. It slows down, the flood wave attenuates, sediment, organic material settle out. This is North St. Vrain Creek, and there were huge effects from this flood elsewhere on the creek, but this part of the creek was very resilient. So, again, this is where it's preaching to the choir. Everybody here knows beavers are ecosystem engineers. They increase that lateral and vertical connectivity, and the vertical connectivity is something that doesn't get as much mention, but it's very important. There's what's called a hyperrheic zone below a river. That just means it's the Greek roots for flow below. So water in the river goes into the subsurface for some distance and returns to the river. It's also called the river's liver. So there are microbial communities that live in the subsurface that remove excess nutrients such as nitrate. And if you're not aware of it, nitrate is a huge issue in our part of Colorado, on the eastern side of the Continental Divide. We have very, very high levels of atmospheric deposition of nitrate. So the more you can get water into the subsurface under stream channels or under floodplains, the more of that nitrate that can be removed. You also do things like cool the water, which of course is very important for many aquatic species such as salmonids. So both lateral and vertical connectivity are important. There's also, of course, surface water storage. There's a higher riparian water table. This is the Fall River in Rocky Mountain National Park, where the Park Service put in beaver dam analogues, but the real beaver are also building very, very nice dams, and they've completely flooded the floodplain. You're looking at the beaver dam in the upper photo. The lower one is where this completely inundated floodplain has return flow coming back into the channel, and the photos were taken in August. So attenuate those peak flows, and that sounds maybe a little intimidating. It just means you slow down the flood peak, so you don't get as much discharge at any one time. It comes over a slightly longer period of time. And the more you can do that, the more you're reducing the energy of that flow. So the more you're reducing hazards to downstream communities, for example, or downstream parts of the river corridor. And I've got base flow increase in parentheses because I think it occurs, but it's been very difficult to demonstrate. That's something that will probably be better demonstrated in future. If you're storing sediment, you may also be storing organic matter. Organic matter is leaves, twigs, pine needles, bits of organic material that are 50% carbon. If they're deposited in a beaver meadow, there's a very high water table. It's what's called reducing conditions. There's not that many microbes that can really degrade that material and release that carbon back into the atmosphere. So you can think of it as a carbon bank. You're depositing this material in a wet environment. If any of you have ever spent time walking around swamps or marshes, you know it's very black, organic-rich soil that smells weird because it's a reducing condition. And the lower photo is from a site on, I didn't make these names up, it's on Little Beaver Creek in the Poudre drainage, and this was after the 2020 fire. These were relict dams and ponds that already had sediment in them, but they filled pretty much to the top with a lot more sediment from the burned areas. And the upper is from the same creek farther downstream where there was bank erosion that's just exposing former beaver dam or beaver pond sediments that are very organic rich. Get the improved water quality of nitrate uptake. If you've got water flowing downstream and it keeps encountering obstacles and spreading into a larger area, it has less energy, so it's less erosive, so you're more likely to have more stable channels. There's greater habitat and quite a lot of biodiversity, and this is my sort of ironic commentary, the moose photo in the center. This was taken in that North St. Vrain Creek beaver meadow. In many parts of the Rocky Mountain National Park, there are no beaver right now because there are so many elk and moose, but hopefully the wolves are going to come on their own soon. Again, you get the increased soil organic carbon stock, and this is getting a lot more attention as people talk about carbon sequestration. There are so many benefits to restoring beavers, and one of them is you also get increased carbon sequestration. So we know from everything from anecdotal accounts of Fremont's and the long expeditions, descriptions of what it was like here in the early 1800s, records from the fur trade, and features like this. This is in the upper part of the Poudre River, just downstream from Poudre Lake on the other side of Rocky Mountain National Park. The dashed lines are indicating a former beaver dam, obviously long abandoned and breached. We know that beaver dams were formerly much more widespread and common in Colorado. And this is from Julie Scamardo's master's work. She used BRAT, which I know many of you are very familiar with, the beaver restoration assessment tool from Utah State University, to just look at where beaver could exist. And this is based on dams per kilometer of river. So the red, not very good for beaver. It's the big rivers, the Arkansas, the South Platte. They were never there. But look at some of the places you might not think about. Way over by the Nebraska border, there are places like the Arickaree River that today do have pretty thriving beaver colonies. And then Julie looked at historic records of climate and land cover, just land cover, to estimate what might have been here prior to fur trapping. And this is a map of the change. So here the red is you've lost a lot of beaver. So we have a lot of places where we can reintroduce beaver. That's why I said the once and future. There were a lot of beaver in Colorado throughout the Intermountain, well, throughout the continental US, except for Florida and the Great Basin. And there's a lot more potential to increase their numbers in future. So a quick conceptual model. Where you have a beaver dam, you can have just a dam and a pond. End of story. If it's a fairly narrow river corridor and it's a little bit steeper, I've seen beavers dams that are built above waterfalls in Rocky Mountain National Park. They obviously really trusted their engineering. That doesn't have much effect though. So what really matters is the valley setting in which the beaver are building dams. So if you're on one side of this threshold, if it's a wide, low gradient valley, then you have this, basically this feedback. So the dam creates a backwater. It is an obstacle to flow, so it enhances overbank flow. That leads to the formation of floodplain wetlands, lakes, ponds, marshes. It's really nice habitat for willows, aspen, river birch, a series of deciduous trees. You get those multiple channels. Basically, the beavers are forcing flow, the beaver dams are forcing flow out of the channel, and it's concentrating into low-lying areas, and the beavers are digging the canals they use to get around the floodplain. Willows are very well adapted to beaver herbivory, so they grow back. So the beaver are basically maintaining their habitat and their larders. So you get more dams and ponds. And if you look at on the upper left here, I've got extensive. It extends across the entire floodplain or valley floor. It's persistent. Because we were working in Rocky Mountain National Park, we couldn't use motorized drill rigs. We were using hand coring, but we got basal dates as the lowest we could go of 5,000 years. And we could see buried beaver dams and ponds there. So they've been there for at least 5,000 years and probably longer in some of these places. It's a very complex or spatially heterogeneous environment, and it's very connected laterally and vertically, not so much longitudinally. On the other side of this, if you lose the beaver for whatever reason, then of course you lose the backwater and the obstruction and the overbank flow. And as the flow concentrates into a single channel, it's got more erosive energy. So that channel is likely to cut downward and to widen, and what you're looking at in those two lower photos are the place that is officially named Upper Beaver Meadows in Rocky Mountain National Park, where there are no beaver now. There's been this incision, and as the channel cuts down, it essentially lowers the water table for the whole valley floor. So it's what ecologists often call an elk grassland, or an alternative state that is also very persistent. It's simpler, and it's disconnected vertically and laterally, although it does have strong longitudinal connectivity. So this upper scenario is more resilient. You get more nutrient uptake for things like nitrate in that hypereic exchange, more carbon storage, and much more biodiversity. So some open questions. Where are these beads that beaver may be able to do really well in? A very simple schematic. This is a river network with lots of beads historically that were very functional for a variety of reasons. I should say that not all beads are beaver meadows. There are beads in forested areas with conifer forests that are really promoted by channel spanning log jams, particularly in old growth forest where you've got a lot of large wood in the channel. Today it looks something more like this. The beads are still there, but they're much less functional than they were. So in the future, it is an open management question. Should we focus more on the headwaters or more on things lower in the system? I've got headwaters in a box for a couple reasons. The work we're doing now suggests that you get more effect if you have a lot of functional beads in the headwaters, and it's also much more feasible to do in the western US because those headwaters are often federal lands. So they're Forest Service, Park Service. As you're all aware, you can have landowners that are very eager to have beavers back and landowners that are very reluctant and more. They don't want beavers no matter what. So other open questions, how do we maintain functionality? What you're seeing in the background here is Hague Creek on the western side it's not on the western side, it's a tributary of the Poudre, but it's across the Trail Ridge in Rocky Mountain National Park. That beaver dam isn't there anymore. I took this photo a few years ago and it hasn't been rebuilt, so the meadow as a whole is drier. And if you're gonna restore different forms of functionality in the beads, how much do you need? Do you need a little bit of connectivity? Do you need 50%, 70%? Do you need 50% or 70% of the beads? We don't know. But I see this as an opportunity for the research community, people like me, to work with the people who are doing things on the ground, who are reintroducing beaver or creating beaver mimicry structures. The one thing I want to end with a nice photo that is not mine. This was in National Geographic, but I really like it. I wrote a book called Saving the Damned about the North St. Vrain beaver meadow. And one of the things that surprised me when I looked back was that there have been waves of enthusiasm for beavers. The whole business of reintroducing them from the air was interesting. But 1930s, the Soil Conservation Service was really pushing beavers. 1950s, there was a big push. 1980s, now we're on another wave. That's great, and I hope this wave lasts more. But I think we have to be very careful because I think this is just something with human nature. We like to simplify and get an easy answer. And I want to go back to what I started with. We have been modifying rivers throughout the temperate latitudes for 200 years. Beavers can do really wonderful things, but we can't put it all on the shoulders of, what did you call it, Emily, a big pond rodent? The beaver were never present everywhere in mountain streams in Colorado. You don't have beaver dams in gorges. That may sound obvious, but I've seen some restoration ideas where people are trying to put BDAs in a really steep, narrow system that's very high energy. We have to think very carefully about where beaver would have been historically and where they can survive today. I also really am dismayed sometimes at the idea that we sacrifice a lot of individual beavers. The relocation efforts have to be undertaken really carefully. And I know if you're here at this conference, you're probably doing it carefully, but I've seen a lot of people, it's just like, well, we'll just drop them off and they'll survive, and they lose half or more of the individual beavers. So we need to think carefully about where they should be, where they can be, and what we can do. But the good news is there's a lot of places that beaver can and should be. So thank you.